All right, let's go ahead and get started. So, hello everybody. Welcome to another Kennametal webinar. Steve George and Danny Davis here.
Hey guys.
Really happy to be with all of you again. So today we've got a really interesting topic. So we want to talk about how to achieve the highest metal removal rates, especially in milling of high temperature alloys. To do that, we're going to have a few friends on with us. We'll introduce those in just a minute. First, just want to say that we hope that everybody's being safe in these challenging times. We're still practicing our social distancing through a barrier here. We've got our other guys spread out in their locations today. So we really hope everybody's being safe and taking care of each other. Before we get into the topic, also want to point out the ability to ask questions. So if you're live and on the webinar right now, we do have a chat window going. You'll see that in the lower right-hand corner of your screen. So you're able to type questions in there. We will answer those as best as we can throughout the webinar. Other ones, if we don't have time, we'll get back to you later. Also, for those of you that are on Facebook, please feel free to comment in under the video. So we'll be looking at those comments and also doing our best to answer all of those questions. And yeah, we see already we've got a lot of people logged in from all around the world, so welcome. So let's get on to our guests today that are going to present the topic. So I'd like to introduce Tim Marshall and Mark Francis. So guys, if you'd please go ahead and introduce yourselves.
Tim, I'll start. My name is Mark Francis. I am with Kennametal Proven Solutions team. I'm a staff engineer there, and my primary focus is on aerospace and defense manufacturing, where we deal with a lot of high temp alloys. Titanium is one of the big ones, along with many others like 15.5 stainless. So typically what I'll do is work with a customer to help them and provide a process which helps them to get a more efficient and cost-effective solution. And today I'm going to be talking quite a bit about that in other areas of this presentation. So I really appreciate all of you joining in, and thank you very much.
Thanks, Mark. Hi, everyone, and welcome. My name is Tim Marshall. I'm a senior product manager for the Untitled milling team for Kennametal. And I specifically look after the shoulder milling platforms, of which HARVI Ultra 8X is one of the platforms. And I really appreciate you dialing in and joining this webinar, because I think we got a lot of good information to share with you, and especially when it comes to being more efficient in machining these types of components with titanium materials. So with that, we're going to go ahead and get started. And Mark and I will share our duties and hopefully go through and answer a lot of your questions as well.
Okay, great. Danny's going to pull up a few videos here so people can kind of get a flavor for the tool, and love seeing these big tips coming off that we're going to look at here in a minute. So I'd love for you guys to go ahead and start and give us a little bit of background about the tool and how the development came about.
Sure. Well, if you think about it, it wasn't very long ago, that aerospace companies, and specifically commercial aircraft manufacturers, needed to make a lot of planes, a lot of parts, okay? And the request came in to help them achieve higher metal removal rates with increased cutting tool times for these particular applications, specifically airframe components, aerospace structural components. So Kennametal has had helical cutters in the past that have worked very well in this area. All right, so we had the opportunity to look at what we had to offer, and then we looked at do we want to use that and update those or modify something like that, or take a step back and come up with a brand new solution. So there was a set of parameters out there as far as I said, as far as tool life goes, as far as metal removal rate goes, for that. We'll talk a little bit more about that after the video.
Cool.
And what everybody's seeing here is just a slotting operation with a 3-inch diameter HARVI Ultra 8X tool, taking a 3-inch deep cut. So it's a square cut 3x3. And that shows about 39 cubic inches a minute of metal removal. And as you can see, those chips are very big. And we had to have a tool that would actually be able to handle that kind of an operation.
Yeah, that's a great cut, Mark. It looks like a conveyor belt of chips coming out the back. I never get tired of watching this. It's great.
I don't either.
So, I think you guys can maybe talk a little bit more about the background of, I know Tim already touched on a little bit just how this tool came about. The challenge that was given to us by the industry as far as developing a tool that would be able to help out the aerospace industry be able to meet the demands that they were faced with at the time. At that time they couldn't make parts fast enough, and it was either buy more machines or figure out a way to make the parts faster. So they came to us asking for us to help solve that. So if you guys maybe can talk a little bit about that challenge and how it was presented to us and how we got started with answering that challenge.
Sure. It started, the tool in front of you was a result of the challenge. And that was the HARVI Ultra 8X that we showed there very, very quickly. But this all started, like I said earlier, about getting higher metal removal rates and more tool life out of these types of tools, these types of applications going forward. And this is a kind of an important chart because there was a current situation where the current tools, the current standards, if you will, had the data there. And then in the future was the challenge or the objective of what they would like to see. Right. So as I mentioned earlier, we could have taken some of our existing tools and tried to modify them to meet the expectations. But the team got together, okay, as we rolled through this, and we said, hey, look, we can definitely meet the challenge, but let's not stop there. Let's see if we can exceed that challenge. So we started from ground up, and what we're going to do as we go through this presentation is talk about some of these small details that were incorporated in the design of the HARVI Ultra 8X to give us the tool it is today. I will say this, we have more than exceeded the challenge on both metal removal rate and also tool life. The product itself has been in the market just under 2 years, and we have seen time after time after time, it has validated those high expectations that we have for this tool.
Yeah, the one thing I see on this slide here, Tim, that we have pulled up is just how far you guys were able to take this. I see in the left-hand side where the current conditions were with our customers, that they were generally running around the 140 SFM range. And the other thing that I really see that stands out is the 10.7 cubic inches of material being removed. And you guys, were asked if you could get up to 175 and up to 16 cubes. But just like you said, Tim, you exceeded their expectations, and we're consistently running at 200 SFM and nearly doubling the metal removal rate in cubic inches of material from what they were doing before. And I think that's phenomenal. It's just a big, it's a big jump from where they were previously.
And one of the things I'm going to throw in there, guys, too, is Danny, you hit a really good point there, going from the slower surface footage the whole way up to clear to 200. What that also does is it gives the ability to get to that metal removal rate without ever changing the chip load. So think about that for a minute. That really saves you a lot of stress on the machine, on the fixture, even on the tool. So what you're doing is you're actually making sure that all the rest of your capital expenditures are being taken care of while you're still increasing your metal removal rates, your productivity, and oh, by the way, we're also doing it more, with less cost per edge.
Yeah, and the other thing I noticed on here is you did that without sacrificing any tool life, which is amazing.
Exactly.
You look at the bottom, we still have 60 minutes of in-cut time on each one of those. And we know, I've seen these tools in action myself, working with you, Mark, and on some of the projects we've done in the past. And I've seen a lot more than 60 minutes. I mean, we've got 90 minutes, 120 minutes tool life with no issues at all. So the fact that you're able to run it at these higher metal removal rates and not sacrifice tool life, which is typically what happens. I mean, usually you start pushing a cutter harder, especially when you start going up in SFM and generating more heat. It seems to, usually be more detrimental to the tool life, and you see tool life going down as metal removal rate goes up. And with this tool, you guys were able to do both, which is really amazing. So
good combination.
Where you can maybe talk a little bit about some of the attributes of the cutter, and maybe we'll go into more detail later, but just some of the high points, I guess.
Yeah, absolutely.
Okay. Like I said, there's a lot of details that went in. Some of them are small, but they are very, very important. Okay. We mentioned about the grade, the KCSM 40 grade. It was actually launched or in the marketplace before the HARVI Ultra 8X tool was developed, but it was a marriage made for this tool, and that allows us to run those higher speeds that we were talking about and get that higher tool life. So in combination with the design of the tool and the KCSM 40, it was a win-win situation there. The other thing about this tool, and if people have taken notice, is it has 8 cutting edges. The inserts themselves have 8 cutting edges. Most of the tools in the market today only have 4. Now, 8 cutting edges, that's not new on an insert. Okay, there's a lot of inserts with 8 cutting edges, but it's new for a helical, right? So as you can see, it's also a negative insert. And during the development, we actually found that even though it was a negative insert, it created less cutting forces than the positive insert, right? So trying to figure that out. Okay, what happened there? How is that possible? And I think it comes down to the placement of the inserts and also the edge prep. We'll talk more about that in a little bit later slide.
Yeah, because that's not typical when you have the negative insert like that to get less cutting forces. So I think that's very unique.
Exactly. And to offer the 8 cutting edges, and Mark alluded to it earlier about the lower cost per edge, to have 8 cutting edges and lower cutting forces. And think about this, these parts are fairly large. These aerostructure component parts are fairly large, so they go on large machines, right? But machines like cutting tools over time, because these are aggressive applications, wear out. So if we develop a tool to give a lower cost per edge because of 8 indexes, and also deliver lower cutting forces, it's going to be less wear and tear in the spindle of the machine. Right. So it's possible that we can actually extend tool life of the machine by implementing HARVI Ultra 8X. Yeah. The other thing about this is we have the full complement of corner radii. We already saw the chip fluid evacuation. That was one of the things that we really had to pay attention to in the design, because when you're talking about the type of metal removal rates we're looking at, Mark alluded to that slotting around 39 or 40 cubic inches a minute. You got to get the chips out of the way. We all know what happens if we pack chips or recut chips.
Absolutely.
And usually bad things happen there. All right. There's some things on the right-hand side I just want to touch on because we're going to talk more about that. We looked at the body itself, the material we're making the body out of. We wanted something that's going to give us good serviceability through the life of the tool. All right, so we have a material that we feel very, very confident in that will do that for us. The other piece of this is PI is a wet machining application when it comes to machining. And we have optimized coolant nozzles for each insert in the cutter. Mark's going to get into more details with that a little bit later. And then the last piece, what you see there in front of you is an integral tool with a KM4X back end. It's a spindle connection, and that gives you the best rigidity possible when you have a monoblock tool or a single piece tool. But we have some other versatile adapters that we're going to talk about as well here. But the KM4X connection does give you that rigidity. And there's a thing called bending moment. Whenever you have a shoulder mill, you have tremendous side cutting forces, especially when you're taking 3-4 inches of axial cut.
Right.
And a heavier radial cut. There's a lot of side force on that. And that bending moment is a critical component that we got to make sure that we understand when applying these tools.
Yeah, I think that's a really good overview. Let's can we jump forward and talk a little bit about the back end? So the BTF46 connection.
Sure. But what you see in front of you on the left-hand side are the standard portfolio. We offer shell mills, and we offer what we call flange mount, and that ties into the BTF46 adapter that we'll talk about shortly. We offer that in inch and metric product, and we also offer 2 sizes of inserts, a 10 millimeter and a 12 millimeter insert. What you see in the middle picture there is more of a pocketing routine, and that's more applicable to these components we're talking about, these airframe components. The tool on the right is what did those pockets. And what you can't see, and maybe Mark, you want to jump in here and talk about the thin wall on the square pocket.
Yeah, and I can do that. One of the things that we see in aerospace all the time is in this photo, you see what we do is we punch a hole in the middle of the pocket and then lower a HARVI Ultra 8X tool in, and we interpolate out. Once we get the original pocket, circular pocket done, then we go back and we square the corners. One of the things we wanted to see in this test, this was during our testing phase, and we wanted to make some thin pockets with deep cuts. So the square pocket actually comes out to a 1/4 inch thick area on the very outside the OD of the pocket, and we wanted to measure the taper. We wanted to make sure that these tools were performing in the best possible way. We don't want to have taper in the pocket. That's not really what the final process needs to be. So we ended up machining it to normal cutting speeds and feeds, and ended up with a 2/1000 taper from the bottom to the top of the floor, or the top of the part. So 2/1000 taper is really nothing.
That's really good for a roughing application.
Yeah, and so the fact is that really told us a lot about the lower cutting forces that we had seen in our load meters and in our feed force meters and things like that. So this actually translates very well into something that any shop could use to get the most out of the tool.
All right, so I have a slide here that shows the BTF connections, and maybe you can talk a little bit more about the flexibility of it, Mark.
Yeah, certainly. And one of the things at the very top of the screen there, you can see stiffer HARVI Ultra 8X. So with the bolt taper flange, the BTF, what we have is the ability to bolt the front end onto the back end, and of course make it a very strong connection. What this really does is through some FEA testing, we found that this connection is 99% as strong as a solid connection or an integral shank. So what we've basically done is we've taken an integral shank tool and made it into an interchangeable back end tool, so we could take what you see there, KM4X back end, and if we had a machine down on the shop floor that had an HSK 125 or a CV50 or whatever, that same back end, except with a different taper, could be put on this same tool. So therefore, you can kind of move that tool around the shop if you need it somewhere else.
Yeah, I got a slide pull up now that shows some of the versatility with the different back ends, but not only the different back ends, but you can put a different front end on that same BTF taper. So that gives you a lot of flexibility in the shop to where you can use some of the same tooling instead of having a modular or integral system where you can only run it on one machine. You can have it where you can run the same cutter body on multiple machines, where you have a HSK 100 on one machine, or 125 on another, or BT50 on the other. So it gives you a lot of flexibility. I like that. That can be very useful, I can see, for a customer to be able to use his tooling on multiple setups.
Hey, so Tim, maybe go into a little bit about the shell mill adapters as well, the extensions, because that's pretty important too for a shop.
It is, and we offer the HARVI Ultra 8X in a shell mill style, both inch and metric. And the adapter or the extension you see there is a standard pilot. So not only can you, attach or use the HARVI Ultra 8X on that extension, you can put any standard face mill as long as the pilot matches up. Mm-hmm. So, for example, from the Kennametal portfolio, if we wanted to use a 7792 high feed cutter, we could do that. Or if we wanted to use a round insert cutter like what we call the daisy cutter, we could attach that to that, and it adds more flexibility and versatility to the machines. Now, what's going to happen in the yellow box there, this fall, we're going to be launching the metric version of those adapters. Okay, so we'll have metric, and the only difference really is not the connection, it's the bolts. Okay, because the inch bolts are here, and the imperial side is here, and we will offer metric, hard metric, for the metric countries, and also those adapters. Those shell mill adapters will be available in inch and metric as well. So it's going to be a really, really robust and versatile program going forward.
Oh, that's good stuff.
Yeah, awesome.
So, guys and folks on the call here, one of the things we mentioned earlier was, we looked at making these tools very adept at doing titanium machining. And typically the big users 6AL4V, but there are other alloys out there like 5553 shown here, or 1023, which is not as easy as 64 either. So what this is just kind of a little indication of what we can do with this tool. This is a 3x7 tool. We actually took a 7-inch length of cut with it, and we were getting running on 5553 typically. A typical carbide would run at 70 or 75 surface feet. These we ran up to 95 surface feet, and the chip load was over 4,000s. And we still got, if you look down there in the bullets, at number 4, the customer, after we got done with our testing and making sure that these tools were working as advertised, the customer actually set his index at 120 minutes per cutting edge. That means that they could move 3 full parts with 1 edge. And that's actually what that boils down to, is 24 parts total before they had to change an insert. And that's economy of scale there for sure.
Yeah, that's amazing. I think about 120 minutes, then multiply that times 8, and that's crazy. So,
and the thing is too, they set their index time at 120, but really, we don't really know what the full life is, because they're working under an assumption that after 120 minutes, something bad could happen, but the edges still looked really good. But 120 is plenty.
Right.
You know what I mean?
Yeah. So I mean, one thing I think of, as machining guys, we think a lot about power, of course.
Mm-hmm.
Machining power, and it's not everything, right? But we know obviously a huge correlation between power consumed, heat generation, and obviously directly forces on the tool, in this case forces on the insert. So we know that there's a big improvement with this tool, and a lot of it, you guys touched on it earlier, but comes from the insert geometry, right? And some of the things that have been done in the insert. So maybe you can talk to us about that a little bit.
Yeah, well, thanks, Steve, and you're exactly right. There was a lot of time and effort put into developing the insert to go with the HARVI Ultra 8X to hit those objectives that we wanted to. Mm-hmm. And if you take a look at this slide, it's kind of gives you a little bit about the detail of the insert. Sometimes we don't look at the edge prep, that type of thing. It's that, but the far left, where the 2 yellow images are, the image on the right is the actual edge of the HARVI Ultra 8X insert today. And we have that land on there for a reason. The land is there to give the edge stability, to give the edge integrity, to give the edge strength in these very aggressive cutting conditions, right? You'll notice if you picked it up, most, if not all, the examples we showed have a feed rate of over 4,000. And that's to get over that land, okay, that's shown there. This being a negative tool, you know, if we don't get over that land and we're hanging out there 7 inches and we have a very small feed rate, it's going to compound that because it's a negative on a negative. Right. So you're actually, the cutting force will actually go up. So it's beneficial to feed it heavier to reduce the cutting forces and get into the positive top rake of the insert over the land and into the positive top rake. All right. So it worked extremely well for these tie applications. What we're seeing now, because it's been in the market for a couple of years, is there are other areas, other materials where maybe we don't need such a strong edge. And that's where the image on the left comes into play. We are going to be having an insert with just a hone and then goes right into a more aggressive top rake. And I already mentioned that, you know, the original HARVI Ultra 8X is 10 to 15% lower cutting forces than some of the positive tools. This insert with just a hone takes that and doubles it again, another 10 to 15% less cutting forces. All right. So it's not available yet, but in the fall it will be. So it's going to add to the arsenal of HARVI Ultra 8X and allow us to go after maybe machines that aren't like the big machines that are on airframe components and those types of things, or some other materials, specifically pH stainless steels and some other things. We actually ran this in Kennametal. And it worked very, very well. So we're opening up the HARVI Ultra 8X from a targeted titanium solution to a more versatile solution to go after more materials. Just real quick, you can see the insert there a little bit better. And on the right-hand side is the biggest insert radii we have, which is a 1/4 inch. I did say that all of these inserts have 8 edges. However, when you get into a certain size of radii, they do go down to 4 inches, but up to the 1/8 inch radius, we have 8. And like I said, the only thing that's going to be where the radius inserts are going to be used is on the front row of the cutter. Everything else will have the 0.8 or 30 thousandths radius up the flutes. So I just wanted to point that out, that the big corner radii only have 4 edges versus the 8 that I've been saying.
Okay. One thing that we can see too, in the view on the right, so the radius insert, one thing I like there is you can see much more clearly the topic surface that you were talking about, Tim. So for viewers looking at it, you know, you're looking directly into it. The insert's there in the center, the square inserts, but on that radius insert, you can more clearly see that top rake surface. Really gives it that positive cutting geometry. So.
Exactly. And the other piece on this, if you look at the insert, it's a pretty plain Jane insert as far as the seating surface goes. And that was designed because we wanted to have that seat between the insert and the cutter, not have any lines or bumps or anything like that. We wanted that insert to be as stable as possible when it's in the cutter. So we removed everything other than the corner radii identification or the geometry identification, right? And that gives us much more seating surface, more stability while these inserts are in that aggressive cutting. So it's a small feature, probably not even noticeable, but that's something that we did during the development to make this tool what it is today.
And I think the edge geometry that you're talking about in this slide is very important because it really shows the versatility of this cutter, and that it's not only versatile in different materials, but like you said, versatile in the type of machine tool that we can use for it. Because, you know, like we said, we've talked about this before, that, you know, not everybody has a T1, T2 type machine, Makino. So for those customers that may have a lighter duty machine or a smaller machine, these tools with just the edge radius on it without the T-land, it could reduce the forces down enough that where they could take a shell mill and still get some real good benefit out of this cutter.
Exactly. Exactly.
So, you know, we saw the video earlier of the HARVI Ultra 8X doing a 3x3 full slot, and we talked a little bit, Tim, earlier about the coolant flow. So maybe we could talk a little bit about the coolant nozzles. And I know that Mark, you gave us a video to show. I'm going to show that video, and I'm going to let you talk through it just a little bit, and then talk a little bit more about the nozzles themselves. So I'm going to pull that up right quick and show it to our audience. This is very interesting to me.
What you're going to be seeing here is we introduced a coolant nozzle structure to especially to our helicals, where there's a lot of chip removal problems trying to get the chips out of the flute before they get caught back up in it. So this is what you're seeing without the nozzles, and this is 200 psi. It really isn't that great of a coolant flow and pressure. So that doesn't really help us too good getting chips out quickly. So with the coolant nozzles in, Danny's gonna show the video, and it's gonna look a whole lot different. It's the same cutter, except instead of just coolant holes, these are coolant nozzles. So you can see that there's a whole big, huge difference in the way that the coolant reacts to these nozzles. And we have been using nozzles since we developed these many years ago, actually, so that there's less of a chance of having any problems with the chips getting stuck in the flutes. And we've been very successful with that. And there are some other kind of fun little facts that I can tell you guys as we go down into the rest of the presentation here. But this is kind of the good thing about the coolant nozzles is they are interchangeable. And if you have a specific type of a pump pressure and a pump flow, we can kind of custom tailor the tool to the right size nozzle. And what that does is that gets you the best coolant pressure for your situation. And it really does make a big difference. I'll tell you, it really does.
Yeah, that's definitely really neat. We talk about tunable tools, and a lot of times we're talking about vibration and things like that. But, to jump into this type of tuning, where you can take into account, like you said, the pump of the machine, the capability of the machine, and directly change those. So like you said, they're all set
Every
up.
situation is different, and you have to be able to handle the situation that comes up. And I think that this is one good, for the coolant at least, this is one good way of at least helping that situation out.
Just think back to the video we showed about slotting. And if you compared the no nozzle coolant flow versus the nozzle coolant flow, and you're a 3x3 slot, all right? So you got to get the chips out of there. And the higher the pressure, the better your options are going to have to get those out of there. And that,
especially vertically.
Yeah, exactly.
Yeah.
So, it's a key feature for the specific application, okay? So, having the pressure there to drive those chips out is just a win for HARVI Ultra 8X here.
Yeah,
and
not
one
only
more point. Oh, go ahead, Danny. Sorry.
That's all right. I was just saying that it's not only to push the chips out, but I think another good point about using the nozzles is how well it directs the coolant where it needs to be. I mean, that's
very true.
Another important thing about coolant delivery is not only having enough coolant, but also having the coolant delivered in the right spot. We've all seen those shops where the operator may have the coolant nozzle pointed at the work holder, on the holder or whatever, and not even directed in the cutting zone. So this is a way that we can make sure that the coolant is exactly where it needs to be in the cutting zone.
And I want to point out too, and some of you all may be looking at the no coolant hole nozzle and saying, why would I want that? One of the cool things about this is that you can, like say for instance, you have a cutter that's 5 inches length of cut, and in this instance you're only taking a 3.5 inch length of cut for whatever you're doing. You can plug those back coolant holes up so that they do not, they don't let coolant out, which gives you more coolant flow where you need it, and that's the reason why we have that.
Yeah, it's amazing. I mean, the tool is so versatile. You can change the inserts to whatever material you're using, or if you're using a lighter duty machine to reduce the forces. And now we can have a different spindle connection in the back with the BTF back end, so we can make it versatile from one machine to another as far as the spindle connection. And now we can also tailor the coolant for whatever their GPM is, or the coolant pressure that they have on their machine. So this is really amazing how versatile this tool is. So
It sure is.
we've talked about the coolant nozzles. We've talked about the inserts. We've talked about the back end. I think one thing that we really haven't spent a lot of time on is the cutter body itself, as far as how important the geometry was on it, and what went into what engineering went into the cutter body itself. So if you can maybe talk a little bit more about that, Mark, I think that would be good as well.
I will certainly do that. One of the important things is that we have at our disposal, and it's a very cool thing, is the ability to do FEAs, finite element analysis. And what that helps us do is it allows us to put the cutting forces in place on all the inserts, and allow us to look at the stresses and the fatigue that's involved in each little machine area of the part. So it surely helped us to design and ultimately make the tools with the least amount of stress designed into them, so that there was less fatigue points and more life we can get out of those without the fear of breaking it. The other thing that we looked at not only was the FEA, but the underlying material had to be right too. So we looked at many different steels, and with the help of our metallurgists, we came up with one that was it's a very structurally sound, I'll say, steel, and it has it's very inclusion free, so it's clean. Which without inclusions, you have a lot less of an opportunity to find a place inside the material that's going to have a stress riser or a fatigue point. And therefore, the combination of the FEAs and using a very, very good steel for the body, we have a tool here that is pretty much second to none in strength for the amount of work it can do. So, and one little fun story is the FEA even helped us to design the coolant holes better and make them stronger, just because we could change the shape a little bit or do whatever, and it actually helped us move the stresses around to a place where they were less likely to cause a problem. So it really is a cool thing.
Yeah, it's amazing what we can learn from the FEA analysis and use it as a tool to improve the cutter bodies, but also the insert geometries and things like that, and to develop more favorable chip formations and things like that. So it's a great tool, and I think it's interesting to me to see all the engineering that went into this cutter from top to bottom. I mean, this was in my eyes the most engineered indexable tool I've ever seen. I mean, it really had a lot of thought put in it. And I know that the engineering on this was spanned over a couple of years, didn't it, Mark?
18 months about between getting the final designs done and tested and tested again, and then taken out to some customers and retested. So yeah, I think Tim said 18 months. That's about where I think we are.
Yeah, I would say a minimum of 18 months. I remember going to one of our labs that we were testing at, and you guys were testing the HARVI Ultra 8X while I was doing some additional testing on some solid milling, and I was just in shock of all the cutter bodies we had. And really, I mean, if you think about it, Kennametal's pretty much spared no expense in developing this tool. There's a tremendous amount of engineering went into it, and I've seen it with my own eyes. I mean, and not only engineering, but expense as well. I mean, there was a lot of titanium cut into chips, and a lot of boxes of chips.
Oh my!
Yeah,
unbelievable.
Labs too.
Well, it's definitely a complicated problem, right? So as you look here in the FEA, I mean, you think about all the possible stress concentrations that you have to think about. You have to think about coupling of different materials and different elements. The the coolant nozzles are now, screws you're inserting, the screws themselves, all of that factoring into the design. It's extremely impressive. And then, like you said, Mark, I think that makes the steel choice even that much more critical, and it's obviously an excellent choice. So,
of course, yeah,
it's great work.
Well, it was a lot of fun developing it and testing it and bringing it out to the world. It was definitely one of my favorite things that I've ever done with Kennametal. And I'm continuing to do that, by the way. If anybody out there needs some help in application, then Tim and I are both here for helping that situation.
And what I'll say from my side, we talked a lot about the engineering and the amount of work that we put into this, and the amount of testing that we've done. Okay. And that was all done for a reason. And that reason was to exceed those goals that we started from in the beginning of this presentation. And we more than did that. Okay. So that hard work of that whole team over those 18 months of failure, okay, and then redesign, remake, it has done a fabulous job of providing a tool to do exactly what we said it was going to do. Right. So I can't be more happy or proud of any tool that I have in my portfolio for the shoulder milling than HARVI Ultra 8X.
I agree. And I'm gonna to end this whole thing, I'm gonna tell just a really quick story that I always feel like it's kind of fun to tell for this tool, and that is during our testing, and I mentioned the fact that we wanted to make a strong tool that wasn't gonna break off in the middle of a cut. That's really never a good situation. We tried to break this tool in testing. I mean, we tried everything we could to make it crash or to fail. We did every kind of a cut that you shouldn't ever do in a shop, and it never failed. It never packed a chip. We never broke one. We never even broke an insert. So I felt really confident and comfortable taking this out to the world, knowing that even, no shop would want to ever try to break a tool. There are mistakes that happen, so we took that into consideration when we tested this and made sure that there was absolutely every possible testing scenario done that we could do to make sure that we could, be comfortable in putting this out there into the public world.
Right.
Yeah. Great comments, and just congratulations to all the team behind this. It's really good work. It's exciting to see. We're guys that we like seeing big chips. We like seeing big cuts. It gets it's fun, right? I mean, we've all been in this business a long time, and you're always trying to top what you've seen before, what you've done before, and things like this is really the things that let you do that and give you that satisfaction. So excellent job, guys, and great presentation.
Yep.
Thank you very much. And thank you. Thanks to everyone who's attended here, and we really do appreciate your attention. And any questions that you have, please make sure that you get them into us, and we'll be sure to take care of them for you.
Yeah, absolutely. So again, if you've got questions and you're watching on Facebook, please enter them there in the comments. We'll do everything we can to get those answered for you. Please contact your Kennametal reps. Feel free to call our CAS department for help, and we'll do everything that we can do to get you the right information and get you using the best possible tools. So again, thank you guys. I think that's a good spot to end, and we look forward to next time.
Yep.
So we'll be
I can't wait.
Absolutely.
It was a good call, and thank you guys for your moderation today. I appreciate it.
No, you're quite welcome. So you guys see come out.
As always. It's a pleasure working with a bunch of guys that know what they're doing. That's all I got to say.
Awesome. Thank you, guys.
Thank you, everybody.
All right. Look forward to the next. You'll see some invitations coming out for more webinars. So thank you. Take care, everybody.
See you.
Bye.